All right, we're going back to a square root here. Okay, that's kind of the first thing you always want to look for. What root are we looking at? Do we look at our cubed root numbers, our fourth root numbers? But this time we're going back to our square root numbers. So that this 2 is just going to stay right out front there for right now. It gets to multiply with whatever else comes out of a radical. So squares, remember, we're looking to try and divide this 50 by numbers like 49 or 36 or 25. You got it. Okay, so 25 times 2 is how we're going to write that 50. Now, m to the second, remember we want to write our powers in multiples of 2. So 3 is not divisible by 2, so we're going to write that as m squared times m to the first power right there. That n, you can't write it in multiples of 2, and the p to the fourth is okay written as p to the fourth. All right, now go through. You're just going to take each of those square roots individually, and then we take the square root of them. So 2 stays, the square root of 25 turns into a plain old 5. No square roots needed, but we do need the square root with that 2 right there. We cannot take this, we can't simplify that any further. Square root of m squared. Remember, when we take the square root of a square, it just goes to m, or you could do power over root, 2 divided by 2. The square root of m, that one's going to have to stay in the square root, as is n, because they don't have powers or divisible by 2. But this one, this p, square root of p to the fourth, turns into p to the second right there. All right, then just go through. You're going to multiply everything outside of the radical together. So anything that's not under a radical multiplies 2 times 5 is 10 times m times p squared. And then under the radical, we have 2mn, 2mn, and that is our answer. Beautiful. Okay, let's try this fourth root. And there's just numbers here. So remember, we want to find powers that are divisible by 4. Okay, so we're going to actually write this as x to the fourth, since we know what the fourth root of x to the fourth is, times, now I need to multiply x to the fourth by 3 more x's, or x to the third, to make that 7. Remember, our exponent rule is say when we multiply like bases together, we could just add their exponents. So I've got to add to that 7 right there. All right, then just take the fourth root of both of those individually. The fourth root of x to the fourth is just x. And this just stays the fourth root of x to the third. And you're finished. That's all you have to do for that one. All right, last example here. Let's choose a fun color. How about this green? All right, it's a cube. Again, that's the first thing I would look at. It's a cube. So we're looking for numbers like 1, 8. What else is on our list? 27, 64, 125. I think we've got a winner. 250 was not on our list. But look right here, we can write 250 as 125 times 2. All right, now we're going to want to write our exponents, if possible, in multiples of 3. So 6 is okay. You're not going to be able to simplify those. So just leave it as x, then y squared, and then z to the 6th. I never write my radical long enough, do I? All right, let's go ahead and take the cube root of each of those. Oops, cube root. Don't forget that it's the third root right there. All right, so the cube root of 125, this was 5 times 5 times 5, which means when I untimes it by that many times, I get a regular old 5. All right, the cube root of 2 is just going to stay the cube root of 2, as is the cube root of x, and it as the cube root of y squared, because I can't divide the 2 by 3. However, on this one, the 6 is divisible by 3. So that means that the cube root of z to the 6th is plain old z squared. All right, and then we can just go ahead and multiply everything outside the radical together, which was just our 5 and our z squared. And then under the radical, we've got a 2x y squared. And you're finished. Look how fun that was. All right, holler if you have any questions on the homework.